Identify the thermodynamic nature of the reaction. The reaction equation is given as CO plus 2H2 is in equilibrium with CH3OH with an enthalpy change of delta H less than 0. A negative enthalpy change, delta H less than 0, means that the reaction is exothermic, meaning it releases a net amount of heat energy to the surroundings. Apply the fundamental rules of chemical bonding and energy. Breaking bonds is always endothermic. Energy must be absorbed from the surroundings to overcome the attractive electrostatic forces holding atoms together in the reactant molecules. Forming bonds is always exothermic. Energy is released to the surroundings as new attractions are established and the product molecules transition into a lower, more stable potential energy state. Set up the relationship between bond energies and enthalpy change, delta H mathematically. The net enthalpy change of a reaction can be expressed in terms of these two competing energy processes. Delta H equals energy absorbed to break reactant bonds, energy released to form product bonds. Compare the magnitudes of the energy terms. Because the reaction is exothermic, delta H less than 0, the value of the equation above must be negative. For the difference to be negative, the energy released during product bond formation must be strictly greater than the energy absorbed during reactant bond cleavage. Energy absorbed to break reactant bonds less than energy released to form product bonds. Select the correct statement. This relationship means that the energy absorbed as the bonds in the reactants are broken is less than the energy released as the bonds in the product are formed, which perfectly matches option C. The correct answer is option C. The energy absorbed as the bonds in the reactants are broken is less than the energy released as the bonds in the product are formed.